Hello everybody, I am Ben from Team Panic, and today we're going to be finishing off looking at my Arduino system that we started looking at last week. Now last week we kind of got to the everything soldered point, but we didn't get to looking at any of the code. So this week I actually have the control box kind of wired up a little bit better, and we're going to have a look at the code and look at how you can modify this protocol basically to do whatever you want it to do in your combat robot. So we're going to first and foremost have a look at just the broad scopes ideas of how everything goes together, and then we're actually going to jump over onto the computer and have a look at some actual Arduino code, the stuff that goes down into these things. We won't really be looking too much at the new controller. It's literally just a housing for the controller that you saw last week. All of the soldering and stuff inside there is basically the same. The only thing is now we've got actual switches hooked up, and we also have a potentiometer hooked up in here as well, which would be for the throttle. We just need to 3D print a throttle and stick that on there as well. Haven't got around to that yet, but that will be out with the files along with this as soon as this video goes live. So now for you, basically. Not now for me, but now for you. All right, anyway, let us stop talking about the controller and start talking about what everything actually does when it comes to getting code from the controller down to the actual receiver module. Okay, so let's talk about what actually gets sent between the transmitter and the receiver. Now, for those of you, just a quick word of warning, this is going to be very, very simplified. For those of you who are looking for like actual RC signals that are being sent back and forth, this is not the video for you. This is going to be very, very broad scopes, and just kind of the underlying principles and not exactly how everything works. So at the very core base level, what we get from the transmitter and send to the transmitter is numbers. So we have an array of numbers. Now we can set this array to be as big as we want it to be. So each of these slots here can take a number, and that number is between 0 and 255. This is for this particular NRF chip. For other transmitters and other receiver modules, they may have a different bounding value here, but for the most part, what happens when you're sending a signal from a transmitter to a receiver is that numbers are flying through the air from one to the other. So in a regular RC system, there is a protocol in place, and each one of these numbers means different things. Now, most of the transmitters that you would see that you can buy have a set number of channels, so they will have like 4 channels or 6 channels or 8 channels, and those will each have their own value, and those will get sent down the line. There is obviously other stuff that's being sent down the line at the same time, but this is the data we care about. There's lots of other things that the transmitter and receiver do and look at to make sure that they're actually talking to the right thing and they're not getting interference and all that kind of stuff. But for the purposes of this, the Arduino library that we're using is going to deal with all of that. So we just need to look at what values we want to send down the line, and also how many values we want to send down the line. Because like I said, at this point in time, we can choose exactly what we want to send down the line. So the best point here is to look at our receiver and work out what we actually need this thing to do. So we need to be able to drive the left motor forwards, the left motor backwards, the right motor forwards, the right motor backwards, and we need to be able to spin the brushless motor. So that is the 5 things that we need to do. Now, in a conventional RC setup, this is channel 1, this is channel 2, and then this here is channel 3 or channel 4. Depending on what your setup is on your transmitter, this is the type of thing that you look at. Now, they do this because it's basically easier for them to set up forwards and backwards on the same channel, and it also means that things kind of sit nicely down into regular RC gear. However, we're not limited to 1 channel for forwards and backwards, 1 channel for forwards and backwards, and then 1 channel for spin. We can actually do this. So we can do our left motor forwards in this channel, our left motor backwards in this channel, our right motor forwards, our right motor backwards, and then we can rub out this end bracket here and add another channel for our spinning brushless motor, like that. So that would mean that we're sending 5 pieces of information down the line, and that's supposed to be a left in there, so we'll just quickly change that. So that's our left motor backwards, our left motor forwards, our right motor forwards, our right motor backwards, and our spin motor. So that is all of the data points that we want to send from this transmitter down into here. And what this means is we can do pretty much everything we need to do over here, and then in the receiver, all we're going to do is we're going to take these values, we're going to do a sanity check to make sure that these two aren't on at the same time, because we can't drive a motor forwards and backwards at the same time. That's not going to do anything for us. Same with these two values. These guys can't be on at the same time. And then finally, we're going to check to make sure that this value is what we need it to be. So these little places can hold a number between 0 and 255. However, the spin brushless motor is going out to an ESC. So that's this guy out here, and that can only accept PWM signals, servo PWM signals between a value of 0 and 180. So when we do our checks on this board, our own internal checks, we need to make sure that this value that we're getting is actually bounded for our brushless motor so that we're not getting junk from our receiver. If we are getting junk from our receiver, we'll have to fix that, but yeah, in this case, we're just going to make a quick check to make sure that the brushless motor controller is going to be happy with the values and the data that we're going to be sending it. Now, these 0 to 255 values work out really well for these other 4, because we can then use those 0 to 255 values and put them straight into PWM, which is the motor controlling signal that goes through a H bridge and out into the motors. I've done a video on PWM before, so I'll link that in the description down below so you can have a look at how PWM works and what it actually does to a motor. Basically, it turns on and off at a set rate so that the voltage that the motor sees looks like it's a half or a third or something, some percentage value of the overall amount of voltage, which makes the motor move faster or slower. So we're going to be sending values down the line that are going to be turned directly into PWM values, and that's because we can set, like I said, we can set this up so that we have the 4 data points we want for all of the PWM values, and then the 1 data point we want for the weapon value, which the weapon motor is not connected to this brushless speed controller right now, but that is where that would go. Now, inside our actual transmitter here, we also have some extra stuff. So we've got our control stick. This is going to be the thing that gets mixed together to give our values that we want for our PWM. So we're going to aim to take the values that come out of this stick, which are from 0 to, I think, 1028 or something higher than that. We're going to mix these values from 0 to plus or minus 255, because of course this is 255 here is going forwards as fast as you can, and a 255 here means going backwards as fast as you can. So that would be a minus 255 essentially. So we're going to mix all of these values coming off this stick to get all of those values, and then we've got our potentiometer over here, which once again will go from 0 to 255. However, the way this potentiometer is set up, it's only going to have about a quarter of its travel. So it's not going to go from 0 to 1028. It's going to go from something like 100 to something like 800 or something along those lines. But you have to check this, and I'll show you how to check this once we get over to the computer in half a second. Then we also have a tiny little screw potentiometer down in here. So this one is actually not going to be to set an actual value. It is going to be a fine-tuning tool. So we can use this to fine-tune the value coming out of this potentiometer over here. So we can use this. Where this is really, really useful is if you're trying to use a potentiometer to lower a flipper mechanism or a lifting mechanism. You can use this potentiometer to lower where this potentiometer starts from so that it actually touches the ground nicely. But this one here is literally just a potentiometer that you can use in your own code to basically meddle with any of these values. If you want to tweak and trim some of these up, you can use a little trim pot to get an extra value that you can then use to trim up your values a little bit. Same thing with the switches on either side. This guy out here at the moment is not currently attached to anything, so that's not going to work. But this guy over here is actually connected up to our switch 1 port, so we can flick that back and forth, and when the switch is pointing down towards these two pins that are connected together, that switch is now closed and electricity will flow through it. And when you flick it like that, the switch is now open and nothing can go through it at all. So once again, this isn't going to manipulate these values directly, but we can use this as like a weapon lockout. So when the switch is closed like this and electricity can flow through, then we're going to ignore the potentiometer over here, which has our throttle on it, and we're going to send a 0 down for our weapon speed. So that would be how you do like a weapon lockout, for example, so that you've got a single switch, which is a weapon lockout switch. Personally, I'd prefer to do that over where my throttle is, but like I said, I haven't got this one soldered up at the moment. This one could be anything else that you like. You could have that as your invert switch, so when you flick this and your robot's upside down, you're going to invert all of your signals coming out of your thumbstick here. So when you do the mixing, rather than sending these values this way around, you're actually going to swap them over so that they actually work correctly upside down. Now, I'm not 100% sure, I haven't actually ever implemented a inverter switch, but that is something that you could do with this, is you could use this switch to tell your controller that your robot is upside down and therefore invert your controls so that while you're upside down, you're still driving as if you would be driving normally, and the robot is doing what you're expecting it to do, not driving inversely to what you're expecting it to do. So yeah, there you go. That is the kind of basics of this. We're going to set up this thing, which is called an array. It's a 5-byte long array, and we're then going to try and populate out all of these 5 values before sending that data down the line to the receiver. And the receiver, like I said, is literally only going to just try and validate these, make sure that these are sane, rational values. And if they are sane, rational values, it's going to generate the signals that all 3 of the motors need, the 2 drive motors and then the weapon motor. All right, so I think that's everything in terms of the kind of how all of this stuff works. So let's jump over onto the computer and have a look at my code.
Okay, so let's take a look at the receiving code first, because it is the simplest of the sets of code. So at the top here we have a bunch of includes, which just include all the Arduino libraries that we're going to need for this code to work. So we have a servo library, which is what's going to run either the servo or the brushless ESC that you use, because the servo or the brushless ESC will both accept servo commands. Then we have software PWM, which allows us to put the PWM for the motors on any pin we like, which we'll set down here in a second. Then we have the actual libraries for the communication module, the NRF24L01 in here. Then we're going to set up a bunch of these things that start the NRF module. So this tells the NRF module it's connected to pins 9 and 10. And we also set up its pipe. So this is the unique identifier that the transmitter and the receiver need to talk on. So if these ever get mismatched, they will not talk to each other. So the only values you can change are the values right at the end here, which for me at the moment are B3. And these are hexadecimal values. So you can put anything between 00 and FF in there, and it will work, as long as I said, the 2 pipes are exactly the same for your receiver and your transmitter. If those are different, then it won't work. So the first thing to check if your receiver is not receiving signals from your transmitter is to make sure that your radio pipe is correct, and that you've only changed these 2 characters here just before the LL, which signifies the end of the pipe, just like that. Then we've got the message, which is the actual data that is going to come in from the transmitter. And then we're actually setting up that servo. We're also setting, these are the pins. So left forwards, left backwards, right forwards, and right backwards. Those are the pins, pin 2, 3, 4, and 5. Then we've got some extra inputs here, or values here, variables here, to hold the values coming out of this messaging block. And then we've also got a no radio value. This is just a safety check. This is how we check to make sure our radio is connected and sending stuff. Then in our setup, we literally just set up the radio itself. We then begin the software PWM and set all of our initial PWM to 0 so that the robot does not move on power up. We start a serial, but that is actually not used in this code from memory, so you can actually comment this line out. And then we connect a servo up to our pin 6, which we soldered up in the last video, and we set no radio to 0 because we haven't actually seen a no radio signal yet. Then we get into the main loop. Now this is the stuff that continues to run all the time, and the very first thing we do is check to make sure that that radio is actually there and actually available. And then if it is, we say that we've seen the radio and that our no radio is 0. And if it's not, then we come all the way down here. This is this else block down here. This is what happens when there is no radio. So here we have no radio equals no radio plus 1. And if we haven't seen the radio for 10 loops, which 10 loops is quite fast when you're not reading the radio. So if we see 10 no radio signals in a row, then we fail safe. So we turn everything off, set the servo to 0, and turn all of the PWMs off so the robot stops moving completely. Now, if you're running a flipper bot rather than a spinner, you're going to want to change the my servo right down here to the safe position for the servo flipper and not to 0, because 0 is going to try and force the servo into the furthest clockwise or furthest counterclockwise point, which is not what you want it to do. You want to set your position for your servo up in here, that is your safety point. But if it is a brushless motor, then setting it to 0 means that the ESC will get a 0 signal, and as long as it's a one-directional brushless ESC, then this 0 is going to give it a stop command, which is what we want it to do. Now let's go up in here and have a look at the actual signal and what is actually happening when you actually get a signal. So first thing we do is read the signal. So we're saying, radio, read a signal that is 5 characters long, which is what we said we were going to do, and we want to read that into the message array that we created up the top here, so message 5. So if you wanted to add a 6-bit of data, you can do that by changing this 5 up here to a 6, and also changing this 5 down here to a 6. Then we are grabbing the actual data out of that messaging block. So messaging 0 is our left forwards, messaging 1 is our left back, and we did this when we're looking at this on the whiteboard, so you know what those are. This is a serial print. You can actually comment this out if you really want to. This will actually slow this main loop down just a little bit, but it's not a huge deal at the end of the day. Then we do our sanity check. So we make sure that our left and our forwards and backwards from both motors aren't on at the same time. So if we see that the left forwards and the left backwards are above 0 at the same time, or the right forwards and the right backwards are above 0 at the same time, then we have our error condition, and once again we stop our motors here. Otherwise, we set our PWMs based on those data values, and we set those out to our PWM pins, which is what these first values are here. Then finally, we double check our actual servo data. So we make sure that the servo data is less than 180. And if it is, we write it out. If it's above 180, then we write a 0, which is our fail-safe condition once again. Otherwise, we write the data across to the servo, just like that. So there you go. That is the receive code. It's pretty simple. It's pretty straightforward. Now we're going to go have a look at the transmitter code.
Okay, so now let's take a look at the transmitter. So this time around we only have the including stuff for the radio. Then we have a couple of potentiometer pins, which are the analog read pins on the Arduino. These are for the up and down on our throttle and the side to side on our joystick, sorry, not our throttle, and then our other potentiometer for the actual throttle, which goes on the other side. Then we have some limits in here. However, these are out of the joystick test program, which I have in the Instructable, and you can find a link to on that Instructable, and the link to the Instructable is in the description, I should say. These uprest and everything, the rest values you don't need to get anymore. I've changed the code so that these are no longer needed. So all you need to know is the up base and up max, the side base and side max, and the throttle base and throttle max. So these tell the controller what maximum and minimum values are for your sticks. So up base obviously being on the joystick, the up and the forwards and backwards direction, and the side is the left and right direction. So push it all the way one way, read the value. If it's a higher value, put it in max and push it all the way the other way, and you'll get a low value, and then put that into the base. And that's all you need out of all of those three. Once again, the test code for that and reading off those values onto a serial terminal is in the Instructables link. Then we have some extra values, which are the variables that hold those values that get read out of the potentiometers. Then we have some mixing values, and then we have some PWM values that we're going to send down the line to the actual receiver. Then we have our radio setup as we had before. Once again, make sure that these two highlighted values in here are exactly the same between the receiver and the transmitter. If they're not, nothing will work. And once again, we have a message pipe that we're going to use to send this message down the line. Setup this time is pretty easy, just a serial begin and a radio begin, and sending out the radio signal by sending out an open writing pipe with our pipe value that we set just before. Once again, make sure that stuff is actually correct and it's going to all talk to each other. Then we're going to actually read the potentiometers that are in the joysticks and the throttle, which is what these do. So these get the value for your up and down stick, your left and right stick, and your throttle stick, and take them and read them into the up, side, and throt values. Then we're going to constrain those. So just in case you have messed up your values, we're going to make sure that this up value, side value, and throt value have to be between the values you specified as base and max. This is particularly important on the throttle, especially if you're not using the whole throw. Something might move and might change, and suddenly you'll be able to push the stick further than you could before. So if you don't do this constraint, or if we didn't do this constraint, that could break the code down below. Then we've got these clearing values, but these are from old code and don't actually need to be there. So I'm going to clean this code up a little bit before I post it. So this may not be posted immediately after this video is released, but it might be Monday before all of this new code goes up on the Instructable. So check back in a couple of days if I don't have the new code in the updated section on that Instructable when you go there. Next, we're going to do a map function. Now this map function takes your values and converts them into different values. So rather than being between 0 and 1020, which is what the up stick is, which is the forwards and backwards stick, that is now going to go from between 0 and 1020 to between minus 255 and 255. So minus 255 is what we're going to say is full forwards backwards, or full force backwards, full speed backwards, and 255 is full speed forwards. Now, the side value is going to do the same thing, but this time we're going to do minus 160 and 160. We can do 255 and 255, that would be full speed left or full speed right. However, I set these down because I find that robots spin on the spot a lot faster than I can react to. So I set these arbitrarily down at minus 160 to 160. If you want your robot to spin on the spot slower, you can change these values even further down. You could put them to 50-50 if you really wanted to, or 60-60. However, I would not advise to do that because we're about to actually do some extra bits down here, which are going to make that a little bit harder to do. So these next pieces of code are your throttle dead bands. So when your actual stick is sitting right in the middle, it's going to have a little bit of jitter and it's going to not sit perfectly in the middle every single time. So you want it so that when the stick stops moving in the middle, whatever value is coming out of that, the robot isn't moving. So that's what this does. It sets a dead band in the middle of minus 50 to 50. So either stick has to go beyond minus 50 to 50 in the scaled numbers to actually start the thing moving. If it doesn't, then what we're going to say is don't move anywhere at all. Like set your value for going forwards or turning to the side to nothing and leave it there. Because we want to make sure that those dead bands exist so that the robot stops moving when you let go of the thumbstick and it kind of centers up on the center-ish point. Next up, we are going to look at actually mixing this. Now, I'm not going to go through all of this code because this does get a little bit complicated as to what's happening and why, but the first stuff of this is if you're not going up and down at all, then you're literally just putting the side values into your sticks left and right, or so you're putting them into your motors left and right. So if you're pushing really hard to the left, then you want your left motor to go backwards and your right motor to go forwards, which is what this does. And if you're pushing really hard to the right, then the side value is going to be negative, which is going to force the left motor to go really fast forwards and the right motor to go really fast backwards. Otherwise, you do this complicated mixing code, which basically sets up the forwards going forwards, and then it subtracts stuff back and forth out of things and makes sure that all of your values are still within that minus 255 to 255 value that we had. So that's a little bit complicated, and to be perfectly honest, some of this code is a little bit mashed together from a couple of different sources that I've found, and it seems to work pretty well, so I don't really touch that for the most part. If you want to do your own mixing of motors, this is where you do that mixing. You can go in here and mess with those values and do whatever you like to it, really. Next up, we map our throttle from our throttle values that we set as base and max to between 0 and 180, because that is the 0 position for our ESC and our maximum position for our ESC. And for me, I had these values backwards, so I did an invert. If your values are the correct way around, you can just comment this line out by throwing a couple of comments lines in there, and that's all good to go. Then, just like we did up the top here, we're going to put a dead band on our throttle as well, which is, in this case, 10 out of the scaled value. So that is between 0 and 10, out of 0 and 180 is your dead band. So until your throttle hits this 10 point, the throttle isn't actually going to send anything out to the weapon PWM. See here, the weapon PWM is 0, just like that. Unless, of course, the throttle is over 10, in which case we send the full throttle value down to the weapon, and everything just works from there. Next up, we actually set those values to what they need to be. So these are the PWM values. So we take our minus 255 to 255, and we convert that to two different values, one for backwards and one for forwards for both motors. So this is the left stack, and this is the right stack. And then once we've got those in, we now have all 5 of our values that are going to be sent down the line to our receiver. So we push them into our message array, and then we write that message out to the radio, which sends it down to the receiver. And once again, we have a bunch of serial prints here, which can be commented out if you're worried about speed, but at the end of the day, that is kind of not all that important. You can if you want to, but it's not necessary. So yes, there you go. That is that code, how all of that stuff works, and yeah, what all of the little bits and pieces do. As I said, I'll kind of clean this code up and tidy it up just a little bit before I upload it up to Instructables. I'll also add in just some commented lines on how you can add switches to things, and how you can I'll add one of those as a throttle lockout switch, just straight up, so that you can just uncomment that code and have a throttle lockout switch on your own controller. All right, there we go. That is that code. Okay, and that is the end of this video. That is most of the code done as a rundown. So that is how you code up one of your own controllers and receiver modules. It is relatively straightforward because the library that runs the NRF chip on the Arduino does a lot of the work for us. We just need to set up that pipe, which once again, make sure your pipes are the same. That is the leading cause of these things not working. Yeah, we set that pipe up, we set up our messages back and forth, and so that the controller knows what it's sending and the receiver knows what it's receiving, and say send. And that is a lot of the actual work that goes into this. The mixing down here, of course, is a little bit more of that work, but I don't really want to go into that code because yeah, it's a lot to go through all at the same time, but it basically just does exactly what you expect it to do. As you push forwards, it adds values to both the left and the right channel at the same time. It adds forwards values to the left and right motor. As you push back, it adds negative values to the left and right motor. As you go left or right, it changes those values up and down so that the robot spins or turns or whatever it is supposed to be doing. But yeah, so there you go. That is that all done. And yeah, I think that's probably going to be the last time I talk about this on the channel for a little while. However, if you do have a crack at making your own Arduino control systems for your own combat robots, please let me know. If you have problems with it, throw us a comment down in the comment section below and I'll try and help out. And yeah, definitely would love to see other people using the system as well, because I mean, I've used it for quite a while now and I've run it pretty flawlessly, so I'd love to see other people picking it up and doing things. Yeah, so there we go. That is the end of that one. And next week, for those of you who made it all the way through to this video, there is something kind of cat-tastic coming next week. We are definitely going back to building combat robots, but this one is going to be a fun one. You are not going to want to miss it. Yeah, so I will see you in the next video.